So I believe the first thing it's asking you to do is to figure out the measure of one interior angle for each one of these. Is that what it says up in the directions there? So if we're taking a look, and we're telling you that they are regular polygons in the directions, so we don't have to have all the markings on there. And so if we're looking at the triangle here, what is then one of the interior angles? Each one would be 60 degrees. Do we agree with that? I mean, you could obviously write it in all three of them if you feel like you need to. That is completely up to you. Okay. The next one is then the square, so one of the angles is 90, pretty straightforward. And here's where your 10-1 day 1 notes could be helpful, because as these get a little bit further along, they get a little bit harder to remember. I think these two, pretty straightforward. I think most of us are going to remember those two. Now we move on to, well, the next figure here on the left is the pentagon, because it has 5 sides. That's probably one of the hardest ones to remember. And one of those angles is, what does it say on your notes? One interior angle. 108, does it really matter where I write it? No. Could I write it on all 5 of them? I could. I'm just choosing to write it on one of them. That's all I'm doing. The next one is 6-sided, so it's a hexagon. And one of those is 120. Again, doesn't really matter where you write it. I'm just kind of throwing it on one of the angles that I come to first. You notice once again we do skip the heptagon, because remember that is actually one of the hardest ones as far as the angle goes. But we do go to this one. Obviously the octagon, and that angle actually probably isn't the best, but it's not too bad. 135. So do we agree so far that finding one interior angle is not that hard? There's many ways you can do it if you have forgotten. For example, let's say we did not have those handy notes of 10-1 day 1. And let's say we were sitting here in an octagon and we had to remember. Well, one way you could do it is this formula tells you the sum of all the interior, correct? And then we could just divide by however many sides we happen to have. So that little formula right there will find you one interior angle of a regular polygon. And so in this one, n is 8, correct? So it'd be 8 minus 2 times 108. Again, this is if, let's say you didn't have those notes handy, and you're just trying to kind of, how do you do that? One angle? And then you would divide by 8. And obviously, in this particular setting, I think somebody reminded us that the division bar almost counts as a grouping symbol. You do the top and the bottom separate. So you look at the top, and then there's another grouping symbol, the parentheses. So we would definitely do the parentheses first. And I think we all know that 8 minus 2 is just 6, right? So you take 6 times 180, divide by 8, and guess what? You get 135. No surprise, right? But again, that's if you forgot. All right? There's going to be a new word today for you. That new word today is apothem. Very big word for regular polygons, apothem. Now, I believe on your notes you have the center pretty much marked for you. Is that correct? You have a dot there marking the center. I'll kind of try and get mine close. That's about maybe where yours is, right? The apothem, and actually a triangle has 3 apothems. We're just going to draw one of them. And what it does is it connects the center to the midpoint of one of the sides. And what normally most people do is they just say, let's just connect it to that side. And it forms a right angle. Very, very helpful. That is the apothem. So how many apothems would a square have if I drew them all? Would obviously have 4 of them, correct? So let's go here. Apothem, and most people, again, just draw the one that happens to go right down to that side. Is that the one you have to draw? By no means, no. You have to draw that one, but you just have to pick the one you are most comfortable with. That just happens to be the one most people will do. So how many would a pentagon have if you wanted to draw them all? It would obviously have 5 of them, and again, that's probably the one most people draw. Hexagon would have 6. Most people just draw that one. Hexagon, then obviously 8 of them. And I'll try and get close. There you go. Okay, so any questions on the apothem? Okay. So that's very good. We did the apothem for all of them. Believe it or not, regular polygons also have something you've heard of before. They actually have a radius, believe it or not. It's the distance where if you had to draw a circle all the way around it, that's where you'd have to put the circle. And basically, I look at it this way, that this one, basically you just connect your center to one of the vertices. Do you agree if I tried to draw a circle all the way around that thing, that's where it should go, right? And again, you could draw any of the three, doesn't matter. Now, which one do you suppose I'm going to draw on the square then? Pretty much the same one, exactly. I'm going to connect that center to one of the vertices. I'm going to draw that one. Again, I could draw a bunch of them. I'm just choosing to draw one. I'm pretty much going to draw the same one in the pentagon. I'm just going to go right from here because I like to keep things the same, keeps it consistent. Can I draw the same type in the hexagon? Well, sure. And the octagon, you can also draw the same one. So far we have a radius and an apothem. And do you agree if you put the blue line and the green line and then that black line at the bottom together on all of these that they do form a right triangle in each case, correct? Well, give or take a little bit on that one. It looks a little off. But the nice thing is that radius does something very special to that angle we just had written there. It cuts it right in half. So it used to be 60, right? So now this portion's just 30. So that's 30. This one here is 90. That one is, oh, well, look at that. That's amazing. Do I also get a 30, 60, 90 in the square? No, because if it is a 90-degree angle and I cut it in half, what do I have now? Oh, 45. 45. Oh, 90. Oh, 45. We've never seen those before. We've never seen either one of these little triangles before, ever. No. Well, what happens here? Ooh, 108. Eesh. But does the radius still cut it in half? Yes, it does. And so this little angle down here is 54. This one here is, well, that's 90. And if you wanted to draw the other one in, it leaves you with 36. Close. So far, would you say that the pentagon kind of the strangest one so far? The other two we've seen, right? Well, perhaps the hexagon will also be a strange one. But wait a minute, 120 cut in half. Oh, there's another 30, 60, 90. And just imagine the heptagon is just a wonderful number. So we'll come to that when we need that one. Because let's face it, the 5, the pentagon was a tough one, so 7's probably not going to be any better. And then we only have one more here, and well, 135, probably not the best, right? What do we get there? 67.5 for this one right here. Oop, you can't really see my point. There you go, 67.5. Which leaves how much for the other one? 22.5, is that right? Yep. Degrees for that angle up there. So any questions so far? We've got an apothem in green, a radius in blue, and now the angle cut in half in red down at the bottom there on all of these, correct? There's going to be two important things to be able to calculate. The two things you're really going to want to be able to calculate are the apothem, if it's not given to you, and the perimeter of your polygon. Those are going to be the two things that are going to be very, very important to you. And so let's go back. Right now, based on this, let's look at the triangle. Can I figure any of them right now? No, because I have given you 0 measurements of sides or any lengths at all. So finding any of that stuff, very difficult. So what I'm going to do right now is I'm going to give you some measurements. So right here, I'm going to tell you that the radius of this is 6 centimeters. I'm telling you that. I'm going to tell you one side of this square over here is 10 inches. I'm telling you the entire side. It's probably important to note that that apothem also will cut the side in half. Okay, the apothem cuts the side in half as well. And let's just go and be creative. I'll give you the radius of the pentagon. So which one's the radius again? green, blue, black. Yeah, blue. 8 meters. So this is a really pretty good sized pentagon. Not quite as big as the hexagon I'm going to give you, though. The hexagon, I'm going to give you the apothem. And so which one's that again? Green. This is a big one. 7 kilometers. That's a really good size hexagon. And on the octagon, I'm going to tell you, what should I give you here? I'm going to tell you that the entire side is, so we go from really big to really small, 6 millimeters. Now what I'm going to do is I'm going to kind of help you through the triangle one, and I'm going to leave you to perhaps your own devices to try and figure out the other ones. Does everybody have them? 6 millimeters, 7 kilometers, 8 meters, 6 centimeters, and 10 inches. So the apothem is the green one here, and so I have to find a way to get over there. Now, I could use law of sines. If you really don't know that cheat sheet very well, you could do sine of 90 over 6 equals sine of 30 over, we'll call it A for apothem, right? You could do that if you're really not good at the cheat sheet. But if you are across from 90, how are you supposed to get to there? Divide by 2, and so across from 30 is just 3 centimeters, correct? And law of sines would have told you that. And so now I also want to find the perimeter of this thing, which means it would be very helpful to know what that is down there, correct? And so how do you get from across from 30 to go and get across from 60? Again, could you use law of sines if you wanted to? Sure, if you're more comfortable with that. But we do multiply by square root of 3. So this side right here, this little piece is 3 square root of 3. And that's just from here to there is 3 square root of 3. Well, this is kind of this is kind of strange. Okay, so for this one, I think we can definitely say apothem, or little a, is 3 centimeters, correct? Big P, which would stand for perimeter, is a little bit more complicated. But I agree that just this little short section is 3 square root of 3. And perimeter is adding up all the way around, correct? How many of those little sections would I actually have in this triangle? Does everybody see 6 of them? Does everybody see that or no? Because I have 1 of those here, right? Then I have 2, 3, 4, 5, 6, right? I would have 6 of those. So if you take 3 square root of 3, and that's a really good 3, 3 square root of 3 times 6. Can I take the 6 times, this 6 times that 3? Yeah. Can I take this 6 right there times that 3 in there? No. So 6 times 3 is just what? 18 square root of 3 centimeters, or centimeters squared? Yeah, very good, because this is just a 6 times that many centimeters. Okay? So that's how you would find the perimeter. Okay, so we can keep going here and get as far as we can, and then I'll leave the rest for you. Well, if that's 10 right there, you should be able to tell me this portion right here. Because if that whole thing is 10, that little red portion I just did is 5. So that's 5 inches. And wait a minute, a 45, 45, 90, isn't that an isosceles? So the apothem is also 5, right? Because isn't that the other one that's supposed to be the same? So apothem is 5 inches. And perimeter, well, perimeter is pretty easy in this one, isn't it? There's not a whole lot of work to do in this one. There's 10 on each side. We know the whole thing, right? Or you could say there's those little 5-inch pieces, that there are 8 of them, right? Either way works. And we come out to 40 inches. So any questions so far? Apothem, perimeter is what we're looking for. And I was trying very hard to get to this one. Do we have a little cheat sheet to get around this particular little triangle? I mean, you could use the 30, 60, 90 cheat sheet, but you're just going to get them all wrong. Okay, and so what you need to do is remember law of sines. And so we have sine of 90 over, well, here's sine of 90. Which side goes with it? 8 equals, now we're going to need both of them. So if we're going for apothem, that would be right there. Which angle am I going to use, the 36 or the 54? Which one, 36 or 54? 54, right? Sine of 54 over little a. And how do we solve these again? I'll give you a chance to write down. Yep. So you take 8 times that, so it's 8 sine of 54 equals a times sine of 90. And so you got to get a by itself. How are you going to do that? Yeah, just divide by sine of 90. And that'll help you. It might be helpful to know that sine of 90 is just 1. That's always a helpful thing to know. And that's how you can find out the apothem. Finish the rest for tomorrow.